Assalamualaikum and hello everyone. Welcome to the video for chapter 7 Haloalkane exercises, where in this video we will discuss the solution for the examples itself. Okay, so let's look for question number 1 here. Okay, for question number 1, it asks you to draw the structural formula of the following compound. Okay, so for the question itself, okay, we have learned the expanded version, the condensed, as well as the skeleton. So it's up to you which one you're comfortable with. For the solution itself here, I will discuss in terms of expanded, condensed, and skeleton. Okay, so first one is third butyl bromide. Third butyl ni is actually, it means that this is our substituent. Butyl, it means that we have our 4 carbon lah. 1, 2, 3, 4 here. But then, because it mentioned about third butyl, so it means that when it acts as a substituent, this carbon is a tertiary carbon. Okay, so when it's tertiary carbon, it attached to 1, 2, 3 here carbon. Okay, so that's why for the third butyl, so this is actually the structure lah. So this is what we call third butyl. Okay, and then bromide, so it means that we have Br attached to it. Okay, for the structure itself here, so here is in terms of expanded. Okay, so in terms of expanded, it will be the most safest way for you to answer the solution is in terms of expanded lah, because it will be easier for you to know how many hydrogen is attached to that carbon itself. Remember that carbon needs 4 bonds. Okay. So this is actually the expanded structure. This is actually a combination of expanded as well as the condensed. Okay, so from here, this is carbon, CH3 here, this one, CH3 down here, and CH3, this one. And then attached to it, we have our bromide in this case lah. Okay, so actually, okay, for the rest of our organic structure itself, for the solution or the structure itself, it's fine if you combine the expanded as well as the condensed structure. Okay, cumanya it will be easier for you to draw the expanded, because then you won't get any wrong answers. But sometimes when you draw the condensed structure, usually the tricky part is actually the number of hydrogen itself lah. Okay, so this one is actually the condensed version, the fully condensed version of this structure. And this is our skeleton. Okay, so for the third butyl, okay, to remember it, macam kaki ayam ni lah. Ni kan bentuk kaki ayam ni kan. And then we have 1, 2, 3, 4. 4 carbon. And on this carbon attached to it, we have another 3 carbon. So this is the third butyl bromide. Okay, next is actually 1 bromo, 1 isopropyl cyclobutane. Okay, so this one is actually the fully expanded version. This is our cyclobutane, and on the same carbon, we have bromo and we have our isopropyl. Okay, so for isopropyl, okay, easy for you is actually for the skeletal structure. Iso ni senang nak ingat ikan lah. Ikan, ekor ikan. So this is our ekor ikan. Isopropyl dengan third butyl lain. Kalau isopropyl ikan, kalau third butyl ni macam kaki ayam. Okay, so this is actually for skeletal structure. Okay, kalau nak gabungkan skeletal di and condensed pun no problem. Yang macam ni lah. Our cyclobutane is actually skeletal, but then the substituent itself we draw in terms of condensed structure. It's just that, remember, for the isopropyl, when it is a condensed structure, sebab bila kita tengok expanded, carbon ni memang attached to it, we have CH3, kan? But then don't forget, we have hydrogen attached to the carbon itself. So that's why we have hydrogen here. Okay, so that's for the 1 bromo, 1 isopropyl cyclobutane. Last one is 4 bromo, 3 methyl, 2 pentane. Okay, so what is the structure? Pentane, it means that we have 5 carbon, 1, 2, 3, 4, 5. And then on carbon number 2, we have our double bond. Okay, carbon number 4, we have our bromine, bromo here. And carbon number 3, we have our methyl. Okay, so this is actually the expanded version. If you want to write it down in terms of condensed, okay, this will be our condensed one. CH3, CH, and then we have our double bond. Okay, here, sini sebenarnya tak ada CH. Just gonna delete this one. Okay, and this carbon we have CH3 attached to it. Okay, next carbon CHBr and CH3. Okay, and then this is the skeletal structure. I believe the skeletal structure is quite straightforward. Okay, next question. Let's look for question number 2. Okay, here it mentioned that a primary haloalkane C3H7Br reacts with aqueous potassium hydroxide under reflux to produce alcohol B. Okay, so here we have our A here, our haloalkane react with aqueous potassium hydroxide. It means co-aqueous lah. Okay, to produce alcohol B. So here is actually my reaction scheme. Okay, upon treatment with sodium cyanide, the sodium cyanide is NaCN. Sodium here Na, cyanide is Cn. A will yield compound C. Okay, however, A will yield a primary amine, D when reacted with ammonia under reflux. So when A is reacted with NH3, we will produce primary amine. Okay, so when we're talking about haloalkane, mostly we will learn about the substitution lah, nucleophilic substitution. Okay, so for the nuclear substitution here, when we react it with our potassium hydroxide, we will substitute OH. When we react with sodium cyanide, we will substitute Cn. Okay, however, when we react with ammonia is actually NH3, we will substitute NH2. Okay, and then we will yield primary amine. Okay, so this is actually the reaction scheme lah. Okay, but then again, what about the structure itself? Okay, so let's look here. We have C3H7Br. Okay, so for C3H7Br, there are two possibility actually when you draw it. Okay, we have 3 carbon kan. Okay, make sure each carbon tu mesti ada 4 bond. Here 1, 2, 3, 4. Here 1, 2, 3, 4. This one pun ada 1, 2, 3, 4. Okay, so when you draw the structure, and then first thing first, okay, you're gonna write down, okay, BR contohnya di sini pun sama jugalah. Ataupun di sini pun boleh juga. So here is the first possibility, and the second possibility is actually when your BR here in the middle. Okay, sebab if you draw your BR, it only has 2 possibility, because if you put the PR here, it's actually your primary haloalkane jugalah. Okay, so when we draw the structure, the naming is different lah. Here is actually our bromopropene. Here is 2 bromopropene. Okay, so it's 2 different structure. But then remember, based upon the statement itself, it mentioned a primary haloalkane. So this is the structure itself. So this is our A. So the question asks, give the structure of compound A, right? Okay, so this is A. Okay, and then we know that when reacted with potassium hydroxide ni, we will substitute dengan OH. So from our bromine here, we will substitute with our OH. So that's why we form B ni, our alcohol itself. Okay, when it reacted with sodium cyanide, we will substitute Cn. Okay, so Cn ni is actually bila kita buat dia as condensed structure. If you want to do the expanded version, actually dia dekat sini lah, C triple bond N. Okay, why C triple bond N? Sebab contohnya bila kamu draw reaction ni, contohnya kat sini carbon, lepas tu sini carbon kan, and then N. Remember carbon ni must have 4 bond. So sebenarnya dengan sini lah 3, 4. Sebab ni 1, 2, 3, 4 untuk this carbon. Talking about this one. This carbon ni memang ada 4 bond pun. 1, 2, 3, 4. Okay, so it's accepted whether you want to write down yang C triple bond N ataupun Cn sahaja pun accepted jugalah. Okay. And last but not least is actually when you substitute your bromine here with your NH2 to produce primary amine. Okay, so this is our NH2. Okay, so for the haloalkane, most of the reaction, the main reaction is actually the nucleophilic substitution. Okay, next one. Here it mentioned to state and show the mechanism for the synthesis of B. Okay, so for the synthesis of B, we want to show for the reaction from our haloalkane to our alcohol. Okay, so from the equation itself, okay, so sebenarnya dekat synthesis it's not NaO, here it's actually our potassium kan, so okay, so from this reaction, we want to know, so here I'm just going to write down the reaction equation. So, we're going to draw the structure itself. Okay, so remember, if anything, yang mainly you have to remember, kalau yang for haloalkane ni, kalau primary haloalkane Rx, it will be SN2. Kalau tertiary haloalkane, it will be SN1. Okay, senang nak ingat ni lah. For the secondary one, it actually depends on the strength of nucleophile. But usually for our syllabus, it's either these two lah. Okay, so this one. Now, let's look for the question itself, because here we have our bromopropane. But then again, what I would like to draw is actually in terms of 3D kan. So, apa yang Miss suka buat, the carbon, the containing halogen ni, Miss yang akan buat jadi macam kita buat yang carbon tu, yang kita nak tunjuk macam ni lah. Remember, we have 1, 2, 3, 4. So, dekat sini, from here, this carbon contain Br, contain two of our hydrogen, and then contain CH3, CH2. This one, I condense it further. So when reacted with OH, we're going to substitute lah bromine dengan OH. Okay, so for the mechanism, it is SN2. SN2 ni dia macam one step sahaja. It's not that one step pun. Okay, tapi what we're going to do, okay, remember OH ni, because it consists of K plus and OH minus. Okay, so what happened here, the nucleophile, kita buat cerita lah kan. Kiranya macam ada orang baru datang nak kacau di relationship ni. So, dia kacau dari belakang. Okay, and then what happened here is actually the carbon ni wants to break the bond with our bromine. Okay, but then here you have to show the state in the middle there. Where carbon ni kita tak tahu nak tinggalkan bromine ke, nak tinggal ataupun nak biar saja OH ni. So, you have to show lah. Dekat sini dot-dot ni juga. Okay, remember here kat sini pun kita kena tunjuk for the other substituent beside the haloalkane ni kena tunjuk in terms of 3D. So senangnya one line, satu dash ni, satu yang wedge ni. Okay, tak kisahlah yang mana-mana. But it is easier for you. Yang dekat sini yang one straight line ni, you're gonna take the longest ataupun the carbon itself lah, the longest number of atom. Sebab bila sini hydrogen, senanglah sikit. Especially bila nak draw sini. Yang panjang tu let it be here. Okay, remember, because this carbon kan attach sebenarnya straight pada CH2 dulu. So, you have to draw CH2, CH3. If you draw CH3, CH2 dekat sini, salah lah. Sebab this carbon attach to CH2 dulu. Macam kita tengok sini. Carbon ni attach pada dia kan CH2. Yang CH3 ni yang paling jauh sekali dengan dia. Okay. So, it must be CH2, CH3. We have to show in the middle here lah. Fasa dia tak tahu nak pilih mana. And then the last one is actually bromine ni sendiri yang akan leave the group. Leave this relationship. So, plus Br minus. Okay, because the electron, sebab once the bond break, the electron will be moving ataupun the electron will be shared. Dia akan split to our bromine. Since it is more electronegative. So, here we have negatively charged. Okay, and then, yang ini kita kira terbalikkan sahaja. Okay, so again, this carbon, dia attached to CH2 dulu. Okay, CH2, CH3. Okay, and then OH ni, tadi dia yang datang kacaukan, tapi carbon pilih dia. Okay, so take that one. Okay, so that is for SN2 mechanism. Okay, so now let's look for question number 3. Okay, so for question number 3, here it mentioned that 2-bromo, 2-metabutane reacts with alcoholic potassium hydroxide solution to give major product E and minor product. E is subsequently reacted with HBr to form F. Okay, name the rule used for the formation of E and then draw the structure and give the IUPAC name for E and F. Okay, so from here, 2-bromo, 2-metabutane. So here is actually 2-bromo, 2-metabutane. So it means that on the same carbon, we have our bromine and our methyl. Okay, it will react with alcoholic potassium hydroxide solution. Okay, so what is actually alcoholic potassium hydroxide solution? It means that potassium ni will react with alcohol. Okay, in this case, in our syllabus, our alcohol that we use usually is actually ethanol lah, ataupun I will use as my etho. Okay, so previously we have seen about the aqueous kan. Kat sini ada aqueous potassium hydroxide. Okay, so what is the difference? Okay, so if the reagent is aqueous potassium hydroxide, what will happen is we will substitute our halogen with OH. If the reagent is actually our potassium hydroxide with alcohol, Okay, what will happen is that we will remove our halogen as well as the hydrogen itself. However, for the removal of hydrogen, we must consider either it's tertiary, secondary ataupun primary lah. Okay, so from this reaction, first our 2-bromo-2-metabutane react with cold ito, it must be reflux lah. Okay, so for this reaction, so when we remove our atom, so it is elimination reaction. For elimination reaction, we will follow the Says's rule. Okay, so again, when we remove it, when I consider here, carbon bromine, okay, carbon next to it, carbon yang on the right of it, on the right side is actually primary, and on the left hand side is actually our secondary. Bila kita tengok yang atas ni pun primary. So when we remove the hydrogen from my secondary here, ataupun secondary here, here will be our major product. Okay, so this one lah. Okay, so they ask you to name it kan. So kita tengok ada 1, 2, 3, 4. So the name will be butane. Okay, but then pada carbon number berapa yang ada, pada carbon number berapa ada double bond. So it's either 1, 2 pun sama jugalah, 2 butane. Okay, but then don't forget, contohnya dekat sini 1, 2, and on this same carbon, okay, contohnya kalau kita tulis sini 1, 2, sini 3, nanti substituent will be a bigger number. So sebenarnya we take, here is carbon number 1, here carbon number 2. Because we want the substituent to be the smaller number. So here dia jadi 2-methyl 2-butene. Okay, so that's the first one. Next, it mentioned that the 2-methyl 2-butene ni will react with HBr to form F. Okay, so when it reacted with HBr, so again, this is actually a reaction from, we have learned about our alkene. For the HBr, this is actually a reagent where in this reaction we will add H and Br to our alkene. But for the electrophilic addition of alkene, we will follow the Markov-Nikov's rule, where hydrogen will be added to the carbon with more hydrogen, while Br is added to the carbon with less hydrogen. Okay, so dalam case ni, for the carbon-carbon double bond, kita check lah. Okay, so here is our carbon-carbon double bond. So this one, the first one ni, attached to it ada satu saja hydrogen. Because attached to here is 1 hydrogen, 1 CH3. For this carbon here, attached to it is 2 of our methyl group. So kat sini dia kosong H ni, dia 0 bukannya OH alcohol tu. Okay, so it means that the carbon itself, the hydrogen itself will be added to this carbon. Okay, yang Br ni will be added to this carbon. Okay, so that is the solution. Okay, and then this, the name of the structure pun sama juga yang ni. The structure is actually 2-bromo 2-methyl butane. Ni sama balik dengan kita punya the first reactor ni. Kita tengok, kan? From here jadi alkene, betul jadi 2-bromo 2-methyl butane balik. So for the case of haloalkane ni, kita akan nampak sikit lah a bit of reaction of our alkene itself. Okay, so this one will follow Markov-Nikov rule. Okay, again hydrogen with carbon more hydrogen, bromine with carbon less hydrogen. Okay, so that is actually for structure, question number 3. Okay, next is question number 4. Okay, so based on the reaction scheme, so kita tengok macam nampak banyaknya, nampak benzene. Tapi let's look for the reaction itself lah. Okay, so here dia minta suggest reagent G. So here is actually our alkene. Again, this is our alkene and this is actually our haloalkane. Okay, so what is actually been added to the solution, to the compound itself? Okay, so kita tengok apa yang beza. Benzene ni tak ada ubah apa-apa. So actually the reaction of alkene lah kita nak tengok. So from here to here, so what is the difference? Is actually we add hydrogen and we add bromine. Macam sama je macam reaction tadi kan, ada HBr. Okay, but it's fine. Let's look here. So when we look at, kita check balik dekat sini. So first, we know that this reaction mesti kita akan add HBr. Okay, but then when we determine the carbon itself, here jadi yang 1 hydrogen, here yang jadi, here we have 1 hydrogen only. This one we have 2 hydrogen. Okay, dalam case ni, hydrogen is added to the carbon with less hydrogen. Sebab remember, here ada satu hydrogen. Tapi dekat situ yang kita tambahkan kita punya H. This one, we have more hydrogen. Tapi dia tambah yang more pula. Okay, macam terbalik pula dengan Markov-Nikov ni kan. So sebenarnya this one memang terbalik. So dekat sini, if your answer is HBr, so incorrect lah. Sebab kalau HBr, carbon kena add to more hydrogen, while Br, carbon less hydrogen. Yang ni macam terbalik kan. So dekat sini H less hydrogen, sini sepatutnya more hydrogen. Okay, so sebenarnya this one will follow anti-Markov-Nikov rule. Anti-Markov-Nikov rule mention that the hydrogen must be added to the one with less hydrogen. Okay, betul tak? Sama. Okay, and then bromine must be added to the carbon with more hydrogen. Sama juga. So sebenarnya for the answer for G ni, it must be HBr H2O2. Okay, tapi kita nak tengoklah, sengaja je nak extra question sikit. Okay, apa yang beza? Ni HBr H2O2 dapat ni kan. Kalau kita add kita punya HBr, remember, dekat sini HBr must follow Markov-Nikov rule. Okay, hydrogen must be added to the carbon with more hydrogen. More ni kat sini. So dekat sini akan jadi kita punya, sini yang kita tambah hydrogen, sini tambah bromine. So terbalik kan. So bila tambah HBr, dia punya bromine dengan hydrogen yang terbalik. Okay, so this is actually for anti-Markov-Nikov. Memang HBr dengan H2O2 sahajalah. We do not have any HCl ke HF ke, tak ada. Memang HBr sahaja. But we must have to follow the anti-Markov-Nikov, mesti ada hydrogen peroxide, H2O2. Okay, yang ini je lah pening sikit. Okay, tapi yang ni dah back to our haloalkane balik. Okay, so next we react it with our KCN. Okay, so for our KCN here, again, what we substitute is actually our CN ni lah. Sebab K ni nanti dah akan gabung dengan BR kita, yang plus KBr as our side product. So, we're going to substitute CN. So, kita substitute lah bromine ni dengan CN. Okay, and then, yang ini we're familiar with. When we have potassium hydroxide, we substitute with OH. So, bromine ni, tak kisahlah nak bawa OH kat sini boleh. OH sini pun boleh juga. Okay, so we have our structure itself. Okay, so when we name the structure, name the structure itself. So walaupun kita tengok sini, carbon sini ada 2, carbon sini ada 6. But then, because we have a higher priority of functional group, so kita kena tengok pada sini lah. Okay, sini ada berapa carbon? Here we have 2 carbon. So dia adalah ethanol. Okay. Tapi pada carbon, remember, we want the carbon that containing the OH2 to be the smaller one. So, kira ni carbon number 1, ni carbon number 2. Okay, here is actually our benzene ring. When we give the benzene ring, when the benzene ring act as a substituent, the name will be 2-phenyl ethanol. Okay, so this is the answer, the name of the structure. Okay, question D. This is question C. Question D, state the type of mechanism for the formation of I. Okay, D, state the type of mechanism for the formation of I. Sebenarnya for the nucleophilic substitution, diterima juga. But then again, because we have learned specifically, kalau for the primary haloalkane, it must be SN2. Kalau tertiary haloalkane must be SN1. Okay, so yang ini betul, tapi lebih tepat lagi kalau kamu buat SN2. Okay, so again, primary haloalkane must be SN2. Our syllabus kita memang yang ni lah. Secondary haloalkane usually it won't be as much, sebab yang ni kena depends on type of nucleophile. Asalnya dekat sini lah. Okay, again, this one pun dah betul, tapi lebih tepat lagi, it's either kalau untuk case yang nucleophilic substitution saja memang kena spesifik lah, SN2, SN1. Okay, so that's for question number 4. Okay, so nampak reaction pun macam ulang-ulang sahaja. Okay, last one. This is actually based upon past year question. So, kita tengok dekat sini, based on the reaction scheme, okay, so daripada kita punya reactor, kita dapat produk. Tapi, actually, from here to here, sebelum jadi alcohol, it will become another new product, and then it needs reagent lah, different reagent. Okay, so let's look here together. Okay, so first question, dia kata, give reagent G and L. G and L. Okay, so kita tengok dekat sini lah. Okay, 4 here is actually our alkane. Okay, if you still remember, kalau kita ingat lah yang chapter 5 kan, yang hydrocarbon alkane. Alkane kita belajar for the reaction is actually combustion, yang kamu kena buat equation tu, dengan yang free radical substitution saja, ataupun halogenation lah. Okay, in this case of alkane, okay, kenapa alkane ni tak banyak reaction? Sebab it is a saturated compound. Dia dah stable by itself. Sebab tu dia tak banyak reaction lah. Kalau alkene yang double bond tu dia unsaturated kan, macam-macam reaction boleh undergo. But for the alkene itself, ada satu saja reaction kita belajar, where we will substitute hydrogen with either our bromine or chlorine. So dalam case ni, kita alkene will only undergo halogenation. Okay, halogenation ni lah. Tapi for the halogenation, it must be Br2 ataupun Cl2 and it must have UV. Sebab UV ni form radical dan because of the presence of radical ni lah, baru alkane ni can undergo the halogenation tu. Okay. Okay, so again yang ni dia tricky part sikit. Sebab yang ni alkane kena ingat balik lah. Boleh satu saja reaction dia boleh undergo. Reaction lain-lain tak boleh. Okay, so what happen next is actually, yang ni mesti terus buat lah. Okay, reagent J. So, it's either Br2UV ataupun Cl2UV. Okay, draw the structure of K. Okay, so what happen here, when we substitute hydrogen with bromine atau chlorine, here we have to consider the classification lah. So, we have our primary, secondary, primary. So, maksudnya ada major, minor product. Even though it does not mention here, this must be major, we have to consider, yang ni memang kita nak major lah. Usually, walaupun tak mention, we have to know ourselves. Okay, so here what does it mean here? Maknanya we will substitute hydrogen yang from our secondary. Kita tak nak yang primary. Okay. So it's either you want to substitute one of the hydrogen here ataupun hydrogen here. Okay, what I'm going to do here is actually I'm going to substitute the hydrogen kat sini lah. So it depends if you answer your reagent here Br2, so sini kena CH3Br lah. Kalau kamu guna Cl2UV, sini kena substitute Cl. Okay, so we will form our haloalkane. Okay, but then the reaction do ask for the reagent L. Okay, so from our haloalkane, macam mana nak form alcohol? Yang alcohol question ni. Okay, so it's either NaO ataupun H2O reflux. Okay, so that is the solution itself. Senang sahaja. Okay, next question. This one we have answer it. C, state the type of reaction. Okay, so type of reaction. Again, for the formation of K, daripada alkane jadi haloalkane, we will substitute it because we have our UV, so dia adalah free radical substitution. And last one, draw the mechanism for the formation of K. Okay, so formation of K ni again free radical substitution. Okay, kalau daripada haloalkane kepada alkohol ni, this is what we call nucleophilic substitution. Okay, so for the draw the mechanism, okay, for the free radical substitution, we have 3 steps. So what is the step? We have initiation, propagation dengan termination. Initiation, okay, for the mechanism itself, only for the free radical substitution ni yang kita guna half added arrow. Okay, again, kalau Miss suka guna yang dot-dot ni, why? Especially memang kena ada dot-dot ni lah, tunjuk the radical, especially the case of the bond here, so it is clearer to you, nampak lah macam mana the electron tu will split. Okay, so initiation, okay, the starting here must be from our halogen tu, kita form our radical. Again, what will happen, this is homolytic cleavage. So when homolytic cleavage, the electron is split equally. Satu dekat this chlorine, another at this chlorine. Okay, so this is the starting of the mechanism. Okay, next is the propagation. Propagation is actually from our alkane itself. From our alkane, it will react with one of the radical here. Okay, again, kat sini, walaupun it is very tempting for you to substitute the hydrogen here, but remember here is primary, here is my secondary, so we have to substitute the hydrogen from secondary, right? Okay, so daripada situ, okay, maknanya kita kena tunjuk lah, yang chlorine ni, dia akan rampas di electron from this bond ataupun dia ambil the hydrogen itself. So kenalah tunjuk yang diorang ni tengah dating dekat satu tempat. And then kena tunjuk juga yang ini yang selalu orang lupa. This one you have to show the bond break. Okay, so it means that this electron is split equally kan. So kena tunjuklah this electron here akan gabung dengan Cl. This electron here split equally will go to the carbon itself. So right now what will happen? This carbon yang akan ada radical. Okay, this hydrogen and the chlorine itself akan form a new bond lah sebab we have 1, 2 electron ni dengan this one electron. Okay, next for the propagation. First kita dapat yang byproduct kita. From the propagation step, we have to show lah macam mana kita akan dapat our product itself. Okay, so from our radical ni, kita tak akan kacau dia dengan radical. For the propagation, dia mesti yang radical ni mesti gabung dengan yang our reactant ataupun reagent kita lah. Reactant ataupun reagent. Okay. So daripada sini, so maknanya pada radical ni dengan reagent kita, Cl2 ni. So again, even though sebenarnya kita boleh, it is fine if you want to draw it in terms of ClCl, but then I would, it will be easier for you to draw the dot, just to show that the electron, senang nampak the electron will be split equally. Okay, so for this carbon, dia nak ambil one of the chlorine, so dia tengah dekat sini. Okay, again, remember, yang ni pun dia nak clash. Okay, so we will form kat sini, maknanya Cl ni akan gabung here, as this one, and then this chlorine will be our radical. Okay, actually sebenarnya this reaction boleh lagi go on lah, propagation tu propagate, dia boleh continue lagi. Sebenarnya chlorine ni boleh kacau lagi hydrogen, sini, sini, all of the hydrogen. But our syllabus, kita belajar mono substitution. So it means that kita punya syllabus, kita just tunjuk satu saja hydrogen tu being substituted, mono kan, satu saja kita substitute. But in actual, in reality, our radical tu boleh substitute all of our hydrogen. Okay, so that is our propagation. Last but not least is termination, where this is the happy ending. Okay, so for the happy ending ni, kita nak happykan kita punya radical. In this case, the radical that form, satu radical ni dengan satu radical ni. Okay, so first, kita bahagikan radical chlorine dengan another radical chlorine. So kita gabungkan, dapatlah Cl2. Okay, and then next one, kita nak happy ending kan, kita punya yang radical yang from our carbon ni lah. Okay, so pada sini senangnya Miss suka rearrange dia supaya dot dengan dot ni is between, supaya dekat dengan yang plus ni lah, supaya nanti senang nak nampak bond dia. Okay, so maknanya yang ni, this one, Miss rearrange sikit supaya nampak panjang macam ni. Okay, and then kita tunjuk sahajalah the dating. Dapat sini. Kalau if you draw in terms of skeletal, so maknanya the 1, 2, 3, 4 kan. 1, 2, 3, 4. So sini 1, 2, 3, 4. So sini dot dot. Lepas tu boleh dah tunjuk sini kan. Sini jumpalah dating mana-mana. Tik tik. So kalau in terms of radical, dia akan jadi macam ni lah. 1, 2, 3, 4. 1, 2, 3, 4. Jadi macam ni. If you draw it in terms of skeletal. Kalau nak condense boleh. Nak expanded pun boleh. Okay, last but not least, we have to show the radical, the combination of radical yang form kita punya major product, which is from here, memang radical kita ni dengan radical yang chlorine kita. Okay, so this is our major product. Okay, so for this one, if you be unsure, nanti Miss bagi link here at the description itself for the link for the mechanism of free radical substitution. Okay, so that's it for this video.